Hello students, welcome to physics virtual class. Today I am going to teach you very important topic of chapter 10 light, that is mirror equation. So students, before proceeding to the mirror equation, we need to first learn sign conventions. So let's start with the sign conventions. Here I have made a ray diagram for you. We can easily locate the different optical distances from this ray diagram. So let me tell you first the optical distances. So students, here I have written U. U stands for position of object. V stands for position of image. F stands for, so please keep this thing in your mind. This is small f, right? Here I have also labeled capital F. So this capital F stands for principal focus, whereas small f stands for focal length. Or I can also write it like this. It is the distance of focus or position of focus. Capital R stands for radius of curvature. So let's have a look at this ray diagram. So students, as you can easily see that it is the ray diagram of concave mirror in which I have placed my object beyond C. Position of the image I am getting here between C and F. Nature of the image is real and inverted, as you can see, and the size of the image is smaller than the size of the object, that is diminished. So in this ray diagram, if I have to label U, V, F and R, so how can I label? See, here you can see A is the position of the object, A dash is the position of the image, and capital F position of the principal focus. But from where these distances need to be measured, this we have to learn using sign conventions. So let's start. So your first sign convention says all distances should be measured from the pole of the mirror. So students, all distances, I mean to say, if I have to measure the position of the object, from where I need to measure this position, that is from pole. So let me complete the sentence. Similarly, if I have to measure the position of the image, so from where I need to measure, it is from the pole of the mirror. Similarly, focal length or distance of F or position of F needs to be measured from pole of the mirror. And the radius of curvature should be also measured from the pole of the mirror. So this is your first sign convention. Let's see next sign convention. Distances measured in the direction of incident ray should be taken positive, whereas in the opposite direction of incident ray should be taken negative. So now what does this mean? So students, let me label here U, V, F and R first. After that we will do the second point. So what is my U? Position of object from the pole. As I told you, the distances should be measured from pole. So here if I have to label here, so I will label like this. So this is my U. Can you see? PA. So here PA is U. Right? You cannot write here AP. So let me tell you, you cannot write AP. Why is it so? Because my first convention says that distances should be measured from pole. So this is the difference between the geometrical differences and optical distances. In the geometry, mathematics, what you do, AP or PA, both are the same thing. But in this case, optical distances, we are very particular that distances should be measured from PA. So I can't write AP, I should write PA. Fine. Similarly, if I have to write V, this is the position of the image. You can see. So let me write, it is PA dash. So here PA dash is V. Now PF. PF is small f and C, distance of center of curvature from the pole. So this is PC. Let me write capital R. So these are the optical distances. Now let's apply the second sign convention. So distances measured in the direction of incident ray. So students, first have a look in this ray diagram and identify the direction of the incident ray. You can easily see that incident ray is going in this direction, right? So let me write here, it is in right direction, right? So this is the direction of incident ray. Now, if I have to measure PA, so I have to go in which direction? Let's see, PA. So I am going in the left direction. Can you see? So what my convention says, the distance is measured in the opposite direction of incident ray should be taken negative. So students, here my PA is equals to minus U. This is how we apply the sign convention. Similarly, let's apply sign convention to the another distance, that is PA dash. So PA dash. So as you can see, again the distance is in the left side and the direction of the incident ray is the same, that is in the right side. So opposite directions. So again, according to my sign conventions, this sign for PA dash will be negative V. Let's have another sign convention, that is PF. So again, find out the direction PF. So again, it is in the left side and the direction of the incident ray is right side. So sign will be my focal length will be negative. Similarly, if I have to find the sign of PC, that is R, again it is in the left side and incident ray is right side. So here you can see that in this ray diagram, all optical distances by applying sign conventions comes out to be negative. So my U is negative, V is negative, F is negative, R is negative. Now let's have the third sign convention, which says heights measured above the principal axis should be taken positive, whereas below the principal axis should be taken negative. So let's apply the third sign convention. So first of all, heights above the principal axis. Now in this ray diagram, you can easily see height above the principal axis, that is AB. Can I write it like this? Similarly, height below the principal axis, that is A dash, B dash, or you can see it is the size of the object. So let me write here, it is the size of the object. Here A dash, B dash is the size of image. So now, according to my sign convention, heights measured above the principal axis should be taken positive. So AB should be taken positive. So if I have to label it, so let me label it with this symbol H. So here H stands for size of the object. Similarly, size of the image. See, below the principal axis, and according to my sign convention, below the principal axis it should be taken negative. So A dash, B dash will be minus H dash. So I will here mention H dash. So from now onwards, when we need to attempt a numerical questions, we can label size of object with H and size of image with H dash, and we can easily apply the sign convention. As you can see, the size of the object is measured above the principal axis always, so it will be always positive. Okay. Similarly, the size of the image, it depends whether the image is real and inverted or virtual and right. So okay, accordingly we can apply the sign conventions. So with this, I hope you have learned how to apply sign conventions, and students, we are going to apply these sign conventions in further upcoming numericals and also in the mirror equations. Okay, thank you.